Welcome to this lecture on environmental impact assessment, a crucial topic in your Principles of Ecology course. As we continue to build cities, highways, and factories, we face a massive challenge. How do we grow our economies without destroying the natural world that keeps us alive? Today, we are going to learn exactly how scientists and policymakers predict and prevent ecological disasters before they even happen. Let us dive in. To understand what this process is, imagine you are planning to build a massive swimming pool in your backyard. Before you even think about digging, you would probably check if there are water pipes underground, if the soil can hold the weight, and if the noise will bother your neighbors. You would not just blindly start excavating and hope for the best, because fixing a broken water main later would be an incredibly expensive disaster. This exact same logic applies to building massive projects like highways or dams in the real world. We need a way to look into the future and predict what might go wrong with nature before we lay the first brick. Now that we have an intuitive grasp, let us look at the formal definition. Environmental Impact Assessment, commonly abbreviated as EIA, is a formal, systematic process used to identify, predict, and evaluate the potential environmental consequences of a proposed project. Crucially, this takes place long before any actual construction is legally approved by the government. The process looks at both the negative and positive effects a project might have on the air, water, soil, wildlife, and even local human communities. By laying out all these potential impacts clearly, decision-makers can decide whether the project should go ahead, be modified, or be completely canceled. Understanding the definition leads us to why this is so critical in the real world. The importance of EIA cannot be overstated, as it is the primary legal and scientific tool we have to prevent irreversible ecological disasters. Without this assessment, a company might blindly build a chemical plant right next to a critical river. This could accidentally wipe out the local fish population and poison the drinking water of thousands of people. By forcing developers to evaluate their plans beforehand, we protect both the environment and human health from catastrophic mistakes. Beyond just preventing disasters, this process also actively improves how projects are built. It forces developers to think about mitigation, which means finding ways to reduce or fix the damage they inevitably cause. For example, a mitigation plan might require a company to plant 3 new trees for every single one they cut down. Furthermore, the EIA process gives local citizens a powerful voice. Public hearings are a mandatory part of the process in most democratic countries, ensuring that the people who actually live near the proposed development have a say in what happens to their home. Now that we understand the social and ecological importance, we must ask, how do we actually measure this? While EIA involves a lot of biology and social science, we also need a way to quantify the damage so we can compare different projects objectively. One of the most common ways to do this is by calculating a total environmental impact score using a weighted sum model. This allows ecologists to assign numerical values to different environmental factors, like air quality or biodiversity, based on how important they are. This mathematical approach removes personal bias and gives us a clear, objective number to work with. Building on that idea of objective measurement, let us look at the actual mathematics. This is the total environmental impact score formula. We calculate this using a weighted sum model. In this equation, I represents the total environmental impact score. The symbol N represents the total number of environmental factors we are evaluating. W sub I stands for the weight or importance of a specific factor, usually on a scale from 1 to 10. M sub I represents the magnitude of the impact, which is negative for damage and positive for benefits. If the magnitude is a large negative number, the total score will drop, indicating severe environmental damage. Now that we have our formula, let us apply it to a real-world scenario. A company wants to build a new textile factory. An ecologist evaluates 3 factors. Water quality is heavily weighted at 8, with a severe impact magnitude of -4. Air quality has a weight of 6 and an impact of -2. Noise has a weight of 3 and an impact of -1. We substitute these values into our expanded equation. The water ecosystem takes a massive hit of -32. Adding the moderate air hit and minor noise hit, the total environmental impact score is -47. This large negative number tells decision makers the factory will cause significant harm, requiring strict mitigation. Having seen how a single project is evaluated, let us look at how EIA helps us choose between multiple options. A city needs to build a new highway and has 2 proposed routes. The factors are forest destruction, with a high weight of 9, and soil erosion, with a weight of 5. For Route A, the forest impact is -2, and the soil impact is -4. We set up our equation by multiplying the specific weights by the impact magnitudes. This gives us -18 for the forest and -20 for the soil. Adding these together, Route A has a total impact score of -38, showing moderate, balanced damage across both environmental factors. Now that we have the score for Route A, we must calculate Route B to make a comparison. Route B has a much worse impact magnitude on the forest, represented by -5, but a very small impact on the soil, represented by -1. Multiplying these out, we get -45 for the forest and -5 for the soil, resulting in a total impact score of -50. When we compare the two, -38 is closer to 0 and less negative than -50. Therefore, Route A causes less overall environmental damage. The city should choose Route A because Route B causes severe damage to the highly weighted forest ecosystem, which drags its score down significantly. With the mathematical comparisons clear, let us zoom out and look at the entire process visually. What you are seeing here is the standard EIA process flowchart. It begins at the top with screening, where we ask if an assessment is even needed. We then move down to scoping to identify the key issues. The third step is impact analysis, where we predict the ecological damage, just like we did with our math formulas. The fourth step is mitigation, figuring out how to fix or reduce that damage, represented by the tree planting icon. Finally, the process ends at reporting and decision-making, where the government will either approve or reject the project based on the data. As we wrap up this flowchart, let us review the most important ideas from today's lecture. First, environmental impact assessment is the ultimate look-before-you-leap tool, allowing us to evaluate consequences before any construction begins. Second, it is essential for preventing irreversible disasters and legally mandates mitigation strategies to protect our ecosystems. Finally, we learned how to use the total environmental impact score to objectively quantify damage, remembering that scores closer to 0 indicate less ecological harm. You now understand how real-world environmental laws use math and science to protect our planet every single day. Great job.